Awesome. Seven, three. Like I said, I'm going to go a little backwards. I'm going to do 7-3 first because I think it will help us with 7-2. 7-3. Simplifying radical expressions. So last class, we simplified things like the square root of 36 equals 6, the square root of 25x to the fourth. And if you remember how we did that, that was 5x squared. There's like a 2 here we don't write. So how many 2's are in 4? 2, or 4 divided by 2 is 2. But what do you do if I give you something like this? Square root of 40. Notice that 36 and 25 are perfect squares. 40 is not a perfect square. How do you simplify the square root of 40? Well, you have to find a factor that is a perfect square inside of 40. So think of things that multiply to be 40. 8 times 5. Is 8 or 5 a perfect square? No. 4 times 10. Oh, 4 times 10. 4 is a perfect square. So what you do is you break this down into the perfect square times whatever is that's not the perfect square. So 40 would be, I put the perfect square first, 4 times 10. That's 40. If I put it together, it makes 40. But I can simplify this because square root of 4 is 2. So my simplification of the square root of 40 is 2 radical 10. So it still could be simplified, not all the time, but most of the time, can be simplified by finding a factor that is the biggest perfect square. Yes, there are perfect squares that will work, but you want to find the biggest perfect square. I'll give you an example as soon as I think of it. Okay, square root of 48. Hi, I know 4 is also a factor of 48, right? So it'd be 4 times 12. But if I look at 12, I have another 4 that's a perfect square. I don't want to use that. I want the biggest perfect square. So if I think about, you can also use your factor tree to figure it out too. So let's do it this way. 4 times 12. This is 2 times 2. This is 6 times 2. And this is 3 times 2. So that's going, that's going, that's going. So I have 2 to the 4th times 3. But I want a perfect square, right? So 2 to the 4th times 3. So 3 is not a perfect square, but 2 to the 4th, 2 times 2, 2 times 2 is 4, times 2 is 8, is 16. That's a perfect square. So I can break down this to be 16 times 3. That means my answer would be 4 radical 3. This is not necessary if you can figure out the biggest perfect square. And after we do a bunch of them today, you're going to get a better feel for what that all means. Okay, so you saw me do it already, but I'm going to give it to you in like math definition. So if you have an nth root of some value times the nth root of another value, they're not the same value, you are multiplying. You can put them together and make a b. You can multiply them together. What you saw me do up top is I took one that was already together, and for instance, I'll put it here. I had, what's the number I had? 40, not fourth root, square root. And what I did, what 40 really is to me 4 times 10. They're separate numbers, right? But what I did, we can break it out into 2 separate factors. Just like when I broke this out to be 4 and 10 so that I can simplify it to 2 radical 10. So you can multiply them together, you can break them apart. Same thing with dividing. If I have some kind of root, and remember, n means any root. It could be square root, cube root, fourth root, and I have a over b, some kind of a divided by b, different numbers. I can break it out into separate pieces. The nth root of a divided the nth root of b. Also, I can take a problem given to me that is already broken into pieces, and as long as the nth root is the same, meaning they're both cube roots, they're both square roots, I can rewrite it as one problem, a over b. They can go back and forth, and we're going to do that a lot today. That's the math definition. So if they're put together, you can break them apart. If they're broken apart, I can put them together. And there's different reasons you want to do each of them, which you're going to see here in a minute. So let's look at some examples just to show you what I'm talking about. So let's say I have the square root of 3 times the square root of 5. Okay, they both are square root. They have the same root. So I can put them together in one problem and make it the square root of 15. Two, the third root of 4 times the third root of 2. Okay, they're both the same root. As long as they're the same root, I can put them together, which is the third root of 8. And now look what happened. I can't simplify that. I can't simplify that, but I can now simplify that because that is just 2, because 2 times 2 times 2 is 8. That's the reason you want to be able to do this, because then you can simplify them. Okay, here's one that's going to be together under a radical times the square root of b over 3. Well, since it's a square root, I can put it together and I can multiply my numerators, 2b, and my denominators, 3a. I can't simplify it, so I'm done. Hey, will you give me 1 second? It's thundering. My dog's having a fit. It's all right. It's right. It's right. I know. I'm sorry. Yes, I'm sorry. You're right. It's all right. It's all right. Right. Give me 1 second. I'm grabbing my husband. He just came out. Okay. He's a nervous dog when it comes thundering. Hey, so usually I sit with him on the couch. Okay, so I have this. They're both fifth roots, which means I can put them together as 1. And when I put them together as 1, don't forget the root. That's 12 x to the 4th y squared. That's the idea of taking them apart and putting them together. I actually think I have a couple more. Hold on. Yeah, I do have a couple more. Hold on. I got more. 5. I can take something like the square root of 5 over 16, and I can break it apart. I didn't do that yet. Notice 5 over 16, I can't simplify, but look what's going to happen when I break it apart. The square root of 5 is, it's not a perfect square, but 16 is a perfect square. So I can simplify this and make it square root of 5 over 4, because 4 times 4 is 16. Six, square root of 40 over 81. Again, I can't simplify that fraction, but I'm going to break it apart and see what I can do. And you'll see what's going to happen if you don't see it already. So I'm going to break it apart, square root of 40 over the square root of 81. So 2 things are going to happen. First, the denominator is a perfect square. 81 is a perfect square, so it's 9. And square root of 40, this is why I started with square root of 40, we can break it down to a perfect square factor times a non-perfect square. The biggest perfect square in 40 is 4 times 10. So my perfect square is 4 times 10 is my non-perfect square, and I can simplify to become 2 radical 10 over 9. Seven. The square root of y squared over 49. I like to start with lots of square roots and then I'll add the other roots in. All right, so I can't simplify that, but let me break it into my 2 pieces. And then we're going to be good because what is the square root of y squared? Well, what times itself is y squared? Y times y is y squared. Remember, there's a 2 here too. So 2 divided by 2 is 1. So it's y to the first power over 7. And all of a sudden, we can simplify it just by breaking it into 2 pieces. And then I have this one. Now I'm into a cube root. Whoops, I did it wrong. This one, I want to go backwards. I have 625 over the cubed root of 5. This is what's cool with this one. I can't simplify them. You can try to 625, but it's not a perfect cube. But if I write it as one big cube, 625 over 5, I can simplify that fraction. So 625 divided by 5 is 1, 12, 2. I know you have calculators, but it's all right. 10, 25. It's 125. The cubed root of 125. Is that a perfect cube? Yes, because 5 times 5 times 5 is 25. I couldn't simplify it here, but I can simplify it once I went here. I got 2 more, then I'll take questions. Cubed root of 27 over 64. Hey, guys, try that one for me. Try it, give it a try. This one's actually a nice one. Okay, so you can't simplify the fraction, but I can break it into 2. And they both happen to be perfect cubes. So 3 times 3 times 3 is 27. And 4 times 4 times 4 is 64. So couldn't simplify it here, but I can simplify it there. That's why you want to be able to think, break them apart or put them together. 10. Last one, I'll take questions. Okay, 5th root of 7 over 32 x to the 5th. I can't simplify the inside, it's already simplified, but I'm going to break it into 2. And by the way, sometimes you can break it into 2 and realize you can't do anything. That's very possible too. 32 x to the 5th. Well, just to sort of show you what I'm thinking in my head, I'm going to break this one down into 2. Again, you don't have to, but I want to show you what I'm thinking. So I cannot do anything with my numerator. There is no perfect cube to get 7, but the 5th root of 32, I believe that's 2. So let's say 2 times 2 is 4, times 2 is 8, times 16. Yep, 2. 2. And if I look at my x, how many 5s are in 5? 1, or 5 divided by 5 is 1. That's an x. And I have it simplified.
The top radical you wrote 3 cubed instead of to the 5th.
Huh, yeah, I did. Thank you. Excellent. Excellent, excellent. All right, any questions? It's all about breaking them apart or putting them together. See if you can simplify. All right, so we're going to go back now a little bit, and we're going to work on what I did with radical 40. We're going to break them into pieces when they're not perfect squares. So we're going to simplify radicals, just like the square root of 40 I did earlier. This is one of probably my favorite ones, something like this, square root of 300. Ooh, that's a big number, but think about your perfect squares. You want the biggest perfect square. So when you see 100, 300, 200, 400, 400 a little different, 500, you should be thinking, oh, it's just square root of 100 times 3, because 100 is a perfect square. What times itself is 100? 10. 10 radical 3. 2. Square root of 45. Not a perfect square, but can I break it down? Is there a perfect square that's a biggest perfect square factor of 45? So the first thing that I don't know, comes to my mind is 9 times 5, right? So 9 and 5. 9 is a perfect square. 9 is, the square root of 9 is 3 radical 5. I just broke it down. Sometimes you might be left with something like this, and it might say simplify, and you're going to say, okay, well, can't do that because there is nothing to simplify, it just equals itself. So if it can't be broken down, it's just going to stay the same, because 15 is only 5 times 3, and neither of them are perfect squares. Now let's look at a cube. Cubed root of 16. Cube roots are harder because you have to think of a number that multiplies by itself 3 times. So you can't be thinking 4, because there is no number that multiplies 3 times to be 4. But if you're thinking 8, you're good. 8 cube root of 8 times the cubed root of 2, because 2 times 2 times 2 is 8. So it would be 2 cubed root of 2. And don't forget the cube. Okay, another cube. Let's do a big fraction cube. Okay, so 3 over 64. I can't simplify it, so I'm going to try to break it into 2 pieces. Okay, there is not a number that multiplies 3 times to be 3. And I mean by number, I mean integer. So that's going to say the cube root of 3. Don't think it equals 1. It's not. It's a number that multiplies 3 times to be 3, and there isn't any. But the third root of 64, 4 times 4 times 4 is 64. So it would break down to the cubed root of 3 divided by 4. And that only happened because we broke it into 2 pieces. Six. Now let's look at, we did this already, but I want to show you one. Actually, let me show you one we did already. Something like this, x to the 12th. This is something we did last time. There's like a little 2 out here that we don't write. Square root means 2. So we talked about thinking about this way. How many 2's are in 12? That's 6. Or 12 divided by 2 is 6. So it would equal x to the 6. It comes out perfectly. But what do you do if it doesn't come out perfectly? Like number 7. Let's say I have the square root of x to the 7th. How many 2's are in 7? Well, it's not going to be even, but I can do 3 because 3 would give me 6. So it'd be x to the 3rd. I can get 3 out. That makes x to 6, right? But I have 1 left over. So what do you do with a leftover? You keep it under the radical. This is what I call my evens. And this is what I call my leftovers. It's not a math term at all. So anything that can divide evenly comes out, and anything that's left over stays under the radical. So just one more time. How many 2's are in 7? There's 3 of them evenly. There's 6, that makes 6, and I have 1 left over. So we're going to start doing this. We're going to start doing things that don't come out very evenly and have different parts. 8. 54. Oh, cube root, sorry. Cube root of 54, x to the 6, y to the 8th. Now we can break it into 3 parts if you want, or we can try to do it in 1 part. Maybe for the first time, we'll break it into 3 parts. Let's break in 3 parts. Okay, 54 times the cube root of x to the 6 times the cube root of y to the 8th. Because we can do that. We can break it into pieces. Is there a number that multiplies by itself 3 times to be 54? No. But we can break that down. What is a perfect cube that we have that's inside the biggest one inside of 54? Well, what I do is I always start by dividing by 2. Well, it's even, I can divide by 2 just to see what I have. So I have 2, 4, 27. Is 27 a perfect cube? Yep, because 3 times 3 times 3. So this breaks down to 27 times 2. I'm just going to finish that off. That means it's 3. 3 is even. My radical 2 is going to be my leftovers. So this is my evens. This is my leftovers. Let's look at the next part. The cube root of x to the 6. How many 3's are in 6? 2. That isn't even. Comes out. There is no leftovers. Even. My y's. How many 3's are in 8? That's 2. Even. Comes out. How many are left over? Leftovers have to be, my cube, under the radical, which should be y squared. So that's a leftover. And then my answer would be 3x squared, y squared, the cubed root of 2y squared. And that is the answer. It looks crazy, but that is the answer. And if you can try to think yourself, my evens go out, my leftovers stay under the radical, you'll be all right. Let's do another one. Let's do the square root. 50, x to the 9th, y to the 6th. Okay, so square root of 50 times the square root x to the 9th times the square root of y to the 6th. I'm going to separate them, but eventually we're not going to have to separate them once we get a little better at this. I have 50. Is there something, the square root of 50, is there some number multiplied by itself to be 50? No, but I'm thinking money. I know it has 25. 25 times 2. Well, that makes 5 radical 2. So I'm going to start right away. So here's my evens. This is my leftovers. So 5 is my even. I know square root of 2 is a leftover. Then I go to my x's. Remember, there's a 2 here. How many 2s are in 9? That'd be 4. How many left over? 1. So even, 1 left over, times how many 2s are in 6? 3. No leftovers. Y to the third. So I have 5x to the fourth, y to the third, the square root of 2x. My evens in front, my leftovers behind. Let's try another one. Fourth root hold on one second, I'm thinking. Of 32, a to the 13th, b to the 15th, c to the 9th. Those all to the fourth root. All right, so fourth root of 32 times fourth root of a to the 13 times fourth root of b to the 15 times the fourth root of c to the 9th. And just to, you don't have to even write this, but this is for me so you know what we're doing. This is my evens, quote, quote. This is not how you talk about in math, but this is how I think about it. Evens, leftovers. Okay, so is there a number multiplied 4 times to be 32? Well, 2 times 2 times 2 times 2 is 16, and 3 times 3 times 3 times 3 is 81, so that'd be no. But if this is 16 times 2, okay, so 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so good. So I know my answer is 2, because this is 2, and then this is going to be 2 left over. Now I'm not going to write this one down, this part down. I mean, the way I did before. How many 4s are in 13? Well, that would be 3. How many left over? 1. Because 4 times 3 is 12, 1 is 13. How many 4s are in 15? That would be 3. How many left over? 3. Because b to the third would be 12, 13, 14, 15, 3 left over. How many 4s are in 9? That would be 2 with 1 left over. So that's my answer. A to the third, b to the third, c squared, the fourth root of 2a, b to the cube, c. Questions? I'm going to give you one here in a minute. Questions? Okay, square root 125, x to the 18th, y to the 21, z to the 32. No, 31. I lied, 31. All right, give it a try. Think evens, leftovers, even leftovers. Break it up any way you need to break it up. Okay, let's do this, see how you did. I know some of you probably aren't done, but that's all right. So if I look at it separately, I would definitely do separately for a while. And then one day you won't have to do it. But okay, there is no perfect cube for 125. Perfect, that's a cube. Perfect square, there is for a cube, not for a square. So I can break that down. Again, I see money. So I think 25 times 5. So this would be my like quote even, and this would be my leftover. So I'm gonna start. So 5 and 5, even leftover. There's a 2 here that we don't write. This will help us. How many 2s are in 18? Or 18 divided by 2 is 9. That's an even. How many 2s are in 21? That would be 10 with 1 left over. And how many 2s are in 31? That'd be 15, that's 30 with 1 left over. And if you got that answer, you did it right. Okay, one more I want to do here that's a little different is this one that we really haven't done too much yet. So 7, the cubed root of 48, y to the 4th. Oh, sorry, it's a big cube. It's a big cube root. No, it's not. I was right the first time. Sorry. I keep looking at the wrong line. Over the cubed root of 2y. I think I might have given it away. All right. Now, I can try simplifying the top, and try simplifying the bottom, but here's your hints. See how they both have a y? And see how these are both even? I'm going to have to simplify it. How can I simplify it? If I put it under one root. The 7 is not under the root, so the 7 is going to stay on the outside, and this whole thing, I'm going to make one root. So I'm going to put 48 y to the 4th over 2y. Why? Because I know I can simplify it. Maybe that will help me. Okay, so when I simplify it, I get the cubed root. Okay, 48 divided by 2 is 24. Y to the 4th divided by y is y to the 3rd. I don't have a denominator anymore. Awesome. So now we got down to a little root. Now, how can I simplify this? Y to the 3rd is perfect. It's a perfect cube, but 24 is not a perfect cube. So, but can we find a perfect cube in 24? 6 times 4 is 24. They're not perfect cubes. 8 times 8 times 3 is 24. 8 is a perfect cube. So 7 cubed root of 8. Is that too big? Times 3. And then we have, of course, our y cubed. All right, 7 is going to stay for a minute, and you're going to put a multiply sign because that's what you're doing. I'm going to show you what's going to happen. The cubed root of 8 is 2. The cubed root of 3, I can't do anything. So that's going to be what I call my leftover. And then the cubed root of y to the 3rd, how many 3s are in 3? 1. That's an even. And then all I have to do now is multiply my constants in the front. 7 times 2 is 14. Y, the cubed root of 3. I'm going to talk about that for a second, what just happened. So if you have, let's say I have just a couple examples. I have the square root of 6 to square root of 8. I need to simplify it. Now, remember, it's a square root. It's not 2 cube root, but 6. I know 8 would be 4 and 2 because 4 is a perfect square, which means what do? You have to multiply them with the radical, and you would have 12 radical 2. So these numbers come together because they want to be integers at the end. So if you ever have a number in the front, like how about -3, the third root of, let's say, 54. That'd be -3 cubed root of 27 times the cubed root of 2. Well, cubed root of 27, 3 times 3 times 3 is 27. -3 times 3, the cubed root of 2, which then makes -9 cubed root of 2. So a lot of times I get questions about what do you do with this number in the front? So you're just multiplying them together. They're just hanging out to the end till you multiply them together. Hey, questions on that? It's gonna take practice, but you guys got this. Okay, so a sort of kind of oddball thing they have in this section is they start talking about something very different. So I'm going to talk about now because in the section, and then we're going to go 7.2, which is going to bring us back to what we're just doing. So remember, they wanted 7.2 first and 7.3 second. That's why this is at 7.3, but I want to talk about now since it's in 7.3. Okay, so the distance formula, actually two, the distance and midpoint formulas. You actually use them a lot in math. I don't know, anybody remember distance formula and midpoint formula?
I was going to ask if those formulas are going to be given on the test. It's Ashley Richardson.
No, you're gonna have to know them. And as you go on to next class, you're gonna learn like quadratic formula, you gotta know that. Like there's certain formulas you just have to know. These are two of ones you have to know. Distance. It's gonna look really familiar in a different kind of format. So, and every book is different. I do it a certain way. You know how slope is y2 minus y1 over x2 minus x1? This is very related because what's distance going to be? Ready? Y2 minus y1 squared plus x2 minus x1 squared. That's your distance formula. Very related to the slope and the way it's set up. So if you know your slope, just remember this is first squared plus this is second squared all under a square root. So if I want to find the distance between this point, -5.8, and -2.2, I would use the distance formula. What would this be used for? To find a side of a triangle, to find the length of a side of a square, to find the length of a rectangle, to find the radius of a circle, if you know 2 points, many uses in distance formula. Okay, so we would do the distance is the square root. Now, just like slope, I'll just label these so you know which ones I'm using, but you definitely don't have to label these by 2. So I'm going to do 2 minus 8 squared, they're my y's, plus my x's, -2 minus -5 squared. This is where you might mess up. Be really careful. It's always minus, and then we had a -5 is separate, minus -5. So this is going to be -6 squared plus, now this one we got to think about, minus a negative means plus. So it's really 7 squared, which equals, hold on one second, 2 minus 8, 6, yep, -2 minus -7. Nope, I just did something wrong. Hold on. Yeah, I did it right. It's not 7. I added wrong. Whew. Okay, it's -2 plus 5, not 2 plus 5, -2, so 3, which equal the square root of -2 squared, a -6 squared is 36, plus 9, which equals the square root of 45. And then guess what? Here comes our skills. Can we simplify that? Can we break it down to a perfect square? Well, 45 is 9 times 5. So my final answer would be 3 radical 5, or 3 the square root of 5. That's my distance. Look at your directions. If it says to enter it in decimal form, you just put square root of 5, put this in your calculator. More than likely, they're going to tell you to put it, this is called exact form, meaning it's not rounded. It is exact number, 3 radical 5. So if you see those words, leave your answer in exact form, it means leave it in radical form. We'll do one more. Same directions, right here is different points. 9, -2, and -3, 2. The distance, if you have to write this down just to get it into your head, please do. That's a really good idea. I should have done it on the first one. I wrote down my formula first, and now I'm going to do plugging in. So y2 is 2 minus y1 is -2. Notice how I have minus -2 squared, plus x2 is -3 minus 9 squared. Now I'm going to make this plus because it's going to be plus. So it's equal to 4 squared plus -3 and -9. That's -12 squared. I can simplify because 4 squared is 16 and 12 squared is 144. If I add them together, I get, let's see, 4, 16, 160. Now, 160. Ooh, that's a perfect square. That's not a perfect square, but it has a perfect square inside. If you're looking at 16 times 10, you got the biggest perfect square. How do you know you have your biggest perfect square? Because there's no other perfect squares left. There is no perfect square in 10. It's done. So my answer would be 4 radical 10. If they happen to give you units, you would put your units after, like feet, inches, centimeters, because a lot of times they're going to ask you to find the distance in like a triangle or something like that. Okay, that's the distance formula. Now here's the midpoint formula. There is no need to memorize the midpoint formula because I'm going to show you a way to think of it without memorizing. So it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. So the midpoint is a point, right? A point in the middle, halfway between. All it's saying is when you take the average of numbers, don't you add how many numbers and divide by how many numbers, right? This is just saying the average of your x's, add the two numbers, divide by 2, right? This is just saying the average of your y's. That's all it's saying. If you can remember it that way, there is no formula to remember. I have 2 numbers, I add them, divide by 2, average. I have 2 y's, I add them, divide by 2, average. That's all it is. Midpoint formula is just the average of your x's and then the average of your y's. All right, so let's look at midpoint. So let's find the midpoint. Between the points, I have -5 and 8 and -2 and 2. So I want to find what point is halfway between those 2 points. So you're going to find the average of your x's and your average of your y's. So -5 plus -2 or -5 minus 2 over 2. 2 numbers I add, divide by 2, that's my average. And then my y's, 8 plus 2, I add 2 numbers, I divide by 2. So what do I have? I have -7 over 2 for my x, and 8 plus 2 is 10, and I have 5 for my y. Done. Just the average of your x's, the average of your y's. Okay, one more. Same thing, midpoint. Here's my 2 points. This time they might label them. Point 1 is P, and then point 2 is, let's say, R. They're just telling you what is geometry. Point P is 1, -4, and point R is 5, 3. That doesn't really matter to us. We just want to find the midpoint. So we take our x's, we add them, we divide by 2, finding the average. We take our y's, add them, divide by 2, finding the average. Then we have 5 plus 1 is 6 divided by 2, which is 3. And this becomes -4 plus 3 is -1 over 2. That's my midpoint. That's halfway between those 2 points. And that is 7, 3. And then we're going to go backwards, do 7, 2. So any questions before I go on to 7, 2? Okay, awesome. 7, 2. Now you're going to see as we go on why I picked 7, 3 first. Let me write this nicer. 7, 2. 7, 2. Okay, this is rational exponents. Rational exponents. We already did rational functions. We did rational equations. What do you remember about rational? Rational means, this is what I think of it as, fractional exponents. They're fractions. Yes, exponents can be fractions. These are exponents that are fractions. Fractional exponents. You've already been doing them. You just don't even realize you've been doing them. So let's look at the definition of a fractional exponent. Where does it come from? So let's say you have a root. We'll call it the nth root. We don't know if it's a 2, 3, 4, 5, and we have an x in the bottom and inside. Really what you have is x is to what power? The first power, right? So this is my numerator. This is my denominator. And what you really have is x to the 1 over n power. It's a fraction. My numerator is the power of whatever's on the inside, and n, whatever root I have, is my denominator, 1 over n. So if I have the square root of, no, let's do third root of 2. 2 is to the first power. It really would be 2 to the numerator is 1, denominator is 3, 2 to the 1/3 power. If I had the square root of 4 to the 3rd, now square root, again, we don't write it, but definitely feel free to put a 2 in there because you're going to need it. 4, my numerator is 3, my denominator is 2. 4 to the blah, 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 I can't speak. 4 to the 3 halves power. Get the gist of what we're doing? If I have, let me do one with an x. If I have x, the cubed root of x, actually, let's put x to the 4th, the cubed root of x to the 4th. that means what I really have is x, my numerator is 4, and my denominator is 3. And we're going to do a whole bunch of problems like these so we can practice these. So numerator is the power. The denominator is the root. Now, before I do anything else, hold on. I could write this one a different way too. There's also another way to write these, which I don't really like this way, but we'll talk about it. Cubed root of x to the 5th power. Now remember, this just means you're multiplying, right? So this is the same thing as saying that. They mean the same thing. So they mean the same answer. X, my numerator is 5, my denominator is 3. So that 5 can go as a power on the outside, or it can become a power on the inside. It means the same thing. You're going to see it both ways. If I have the square root of y and I make it to the 9th power, remember this is a 2, so it would just be, well, I'm going to write both ways. It's just also means the square root of y to the 9th. They mean the same thing. So y, numerator is 9, denominator is 2. So you're going to see it both ways. So let's do let's do a lot of examples. Okay, examples. And this is all simplify. I'm going to start just with numbers, and then we'll go and throw some variables in. So 81 to the 1/4 power. All right, what I always do, I rewrite it as a radical. That just means the 4th root of 81 to the 1st power. I don't need that power. So it's just saying the 4th root of 81. Is there a 4th root of 81? 3 times 3 is 9. Yep, I think it's 3. 3 times 3 is 9, times 3 is 27, times 3, yep, it's 3. 81. They mean the same thing. Different way to write the answer means the same thing. Different way to write the problem, not the answer. All right, 64 to the 1/3. That would be the cubed root of 64. Now I'm not going to write the 1 because I don't need the 1. Is there a number multiplied 3 times to be 64? Yes, that would be 4. Be really careful of this one. Negative 16 to the 3/2 power. 2 reasons. See this negative? It is separate. It's like saying negative 1 times 16 to the 3/2. They're very separate. It's not negative 16. The only thing that's being to the 3/2 power is this. There's no parentheses. Versus if I gave it to you this way, then that means both of them get the negative also gets the 3/2 power. But that's not what I said. Negative is by itself. All right, so it is negative square root of 16 to the 3rd power. Why did I do it this way? You'll see why in a second. All right, equals negative. What's the square root of 16? That would be 4 to the 3rd. And then negative 4 to the 3rd is 64. Negative 64. Now we could do it the other way. Negative 16 to the 3rd. They mean the same thing. I don't have my calculator, do I? No, I don't know what 16 to the 3rd is. Equals, I don't like this way because it gets to be a big number. 16, anybody have 16 to the 3rd? Tell me what it is. 4,096. You guys have calculators, so it really doesn't matter. But if you didn't have a calculator, I don't know what the square root of 4,096 is, but I bet you it's going to be 64. So negative 64. This way is easier to do these problems than this way when you have to compute them. 4. Okay, look at x. X to the 1/4 power just means the 4th root of x. Five. 9, a to the 4th, b to the 8th, to the 1/2 power. Well, if I rewrite this, we just did these problems. 1/2 means the square root. There's a little 2 here. There's 9, a to the 4th, b to the 8th. These are like our evens leftovers, right? But I think they're all even. The square root of 9 is 3. How many 2's are in 4? 2. They're all evens. How many 2's are in 8? 4. Answer. So I don't leave it in 1/2. I rewrite it as a square root or root. Hey, questions before I go on? Anything? All right, let's look at this one. 32, x to the 10th to the 1/5. Again, I can rewrite it as a 5th root. 32, 10, whoops, how about x to the 10th? X to the 10th. And now I can think about each one. Is there a number multiplied 5 times to be 32? Yep, 2. How many 5's are in 10? 2. 2x squared. Answer. Seven. 16 x to the 7th to the 1/3. Well, that would be the cubed root of 16 x to the 7th. There is no number that multiplies 3 times to be 16, but I know there's an 8. Cubed root of 8, cubed root of 2. That's my square, that's my cube root of 16. And then I have, so let's do even, okay, before I go on, even leftovers. Okay, so this is equal to even leftover. How many 3's are in 7? That would be 2 even with 1 left over. See why I did the other section first? Sort of kind of backwards. It's just like we did, but it's with a different way of looking at it with a fractional exponent. They mean the same thing. 8. 81 m to the 5th, n to the 19th, p to the 32. All to the 1/4 power. Again, I rewrite it as a 4th power. 81 m to the 5th, n to the 19th, p to the 32. And then we're looking at problems we just did. Now, 81 happens to be a perfect 4th power because I think it's 3. 3 times 3 is 9 times 3 is 27 times 3, 81. Yep, so this is 3 even. M's, how many 4's are in 5? 1 with 1 M left over. How many 4's are in 19? That would be 4. That's 16. How many are left over? 3 to make 19. How many 4's are in 32? That would be 8. And that's the even. There is no leftovers. And there's my answer. Now here's a weird one. Negative a to the 3 halves b to the 9th, c to the 6/5, all to the 2/3 power. Now this one has all fractional exponents, so this one I do differently. I only do the root thing if they're all integer exponents on the inside and then just a fractional on the outside. Then I'll rewrite it as a root. I just think it's easier to look at. This one, we're going to have to use our exponent rules. So we have a power to a power. So we're going to multiply all our exponents. So we have negative 1 to 2/3. I'm writing that for a reason because we got to think about, is it going to be negative or positive, right? A times A, the 3 halves times 2/3 is just 1. I don't have to write 1, but it's 6/6, which is 1. B, 9 times 2 is 18, divided by 3 is 6. And then C, I'm just multiplying denominators and numerators. 6 times 2 is 12, divided by 15. I'm gonna write that down, but I gotta simplify it. So I'll just do it a second. Divide by 3 would be 4/5. So I'm not gonna change it, 4/5. I couldn't do it in my head for a second. I gotta write it down. So 4/5. Okay, so A, I don't need that. B, I have to the 6. So already I have an even, I have an even. This is gonna be my leftover. What is this? So what is -1, the cubed root of -1 squared? Well, the cubed root of -1 is -1, but as soon as I square it, it's +1. So I don't need it anymore. You even have to think about the negatives, whether it's negative or positive. So 1, I don't need it anymore. So what's my answer? My evens are A, B to the 6. The only one that's a root is C to the 4th. Now, it's also very possible they ask you to keep your answer in exponent form, and you would just write this. So this should be radical form, simplified radical form. This should be simplified exponent form. They could ask you to answer either way. Put it in radical, leave it in exponent form. All right, 10. Let's look at 4 to the 3 halves power. So I want you to think it as this way. It's the square root of 4. That's the 2. That's the root, right? Root. This is the power. All to the 3rd. It's much easier to figure this out. Square root of 4 is 2, and 2 to the 3rd is 8. And guys, I really don't want to use your calculator too much. I want you to try to use a calculator for a little bit. I don't know if your next teacher is going to have you let you use a calculator. It all depends on who you have and who they are. I don't know anybody there, but I've already heard that some people calculate, some people not calculators, et cetera, et cetera. So do these without a calculator. Do not rely. A calculator is the easy way out. Do this by thinking. Don't do a calculator for the beginning. -8 and 4/3. Now, negative is not in parentheses, is it? Nope. So negative is just hanging out in front. So negative, I'm going to rewrite this as the cubed root of 8 to the 4th power. Now we're going to simplify. Negative parentheses, the cubed root of 8 is 2 to the 4th power. Notice how the negative is just hanging out. And 2 to the 4th power is 2 times 2 is 4 times 8, -16. Now I'm going to have parentheses, -256 all to the 3/4 power. Okay, so it's in parentheses. So we have to think of it in parentheses. So we are going to go negative 256 to the fourth power, sorry, fourth root to the 3 power. But can we have a negative under an even root? No. So not a real answer. So always be careful of, you can have a negative under an odd root. You cannot have a negative under an even root. Fraction, 9/4 to the 5 halves. Remember, we can split them, right? 9 to the 5 halves over 4 to the 5 halves. Why would I split them? Because I can't simplify that fraction, but I know I'm dealing with a square root. Then I'm going to rewrite it. It's the square root of 9 to the 5th power over the square root of 4 to the 5th power, because this is my root and that's my power. Okay, so square root of 9 is 3 to the 5th power. The square root of 4 is 2 to the 5th power. I could put it together as 1, but I can just do it separately too. So 3 to the 5th power. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, 243. 2 to the 5th power is 32. Can I simplify that? Nope. That's my answer. You could put it in mixed numbers, but that's my answer.
Will we take a short break?
Say again.
Take a short break, a bathroom break?
Yeah. What time is it? 3:21. Yeah, we can take a short break to the bathroom. 5 minutes. 5 minutes. 5 minutes.